So I'll get started. Before that, a slight introduction about me. So hi, very good morning. My name is Aman, and I'm having around 5.2 years of experience in the field of data science. And my experience is purely into this data science and GCP side. So I started my career with AI, ML, data science, and machine learning, and primarily I'm working all this tech stack in the GCP sites while creating anything from scratch to this deployment. So I use GCP as my primary what you can say infra provider, and for that, other sort of tools and technologies required from GCP's end, I'm gonna use them for making my model productionizable and deployed. So that's something about me, and let's get started to this journey of GCP AI. So here, what are sort of models of introduction and syllabus is there? We have created a simple list of introduction and divided these models into simpler terms, and getting started over that. So yeah, that's something. Yeah. So coming to this, okay, I'll start with this introduction simple way. I'll just design it in such a way that anyone who is getting apart from AIML and wanted to invest in this side can get some what you can say understanding in simple words. So while working with the GCPI, one should know about AI and ML. Since I believe this course is personally what you can say designed on the data science point of view and Vertex AI point of view. So there are some key concepts like what is AI ML, what is the types of AI ML learning, what are some core GCP services that we can use for this technologies, why GCP is an excellent choice, and comparison of GCP with other cloud providers. And then as we are getting started, I just kept one hands-on demo like how we can use some API and services credits service in this GCP, and how we can access it that with our simple flow. So that is something that is agenda that I divided in this typical discussion. So coming to introduction of AI ML, we are gonna see what is AI, what is ML in layman's terms, simple layman's terms, nothing technical, nothing complicated. Like in coming to the second key concepts, what is supervised learning, what is unsupervised learning, and what is reinforcement learning. So we have divided these types of machine-based ML-based learning into supervised, unsupervised, and reinforcement learning. So what is that? We are gonna see that. Then there are some core GCP services for AI. These services are typically used for what we can say developing and deploying ML-based model or AI-based model, and how we can use them. So this is some core services one working in data science AI ML should know. So that is something that we have been working on. So then, why GCP is an excellent choice for AI ML projects? Why we are going to focus on GCP rather than other cloud providers, and what is the upper hand that it has while working with AI and ML? So this is something that we are gonna look at again, and then comparison of GCP with other cloud providers. So there might be some comparison, right? So I think comparison will make our learning easier. So I just compared this point of view, and we're just gonna take a look at that as well. So let's get started with the introduction of AI and machine learning. So AI is something that we use machines to think like human and ask the machine to work like human. So it might work from starting from simple classification problem to work with more complicated problems. So such that you can see like we are working with generative AI technologies right now. Okay, so it's a part of AI as well. So AI will ask human. Sorry, AI is the branch where we ask machines to act like human and make some sort of decisions. So it will allow computers to think, analyze, reason, and make some decisions. So AI is what we can say superset of all sort of technologies working around data science. It started from machine learning, involved with deep learning, natural language processing, computer vision, and currently generative AI. So these are some small sort of subsets out of which AI is the bigger box that we look at. Okay, so ML, machine learning, is the subset of AI that will enable computer to learn from the data and improve their performance. So let's say where there is some scenario where we are having some sort of data. The data is kind of the data is kind of labeled or unlabeled. So at that time, while looking at the data, we can make some assumptions or derive some decisions based on that data. It might be classification or regression. So that is some use cases that we can look at ML-based problems and work on that. So ML is a subset of AI that allows computer from the patterns from the data and improve their performance without getting any sort of programming with that data. So ML is a bigger subset of AI that has worked over these long years and evolved this AI from ML to these currently generative AI technologies. So ML is a kind of foundation of this AI, I believe, while working with this any sort of programs or what you can say any sort of things. One should be aware of what is AI and what is ML. So coming to this evolution of AI from ML, there are, as I already mentioned, these things came into market like deep learning, natural language processing, and generative AI. So over these applications, we can classify AI while using with this application as well, such as speech recognition, recommendation system, autonomous vehicles, and even processing. So AI has evolved around significantly. Like initially, we were working typically on rule-based system. So while developing a chatbot as well, we were initially working on rule-based chatbots. Then later on, like complicated system, like not just complicated, more advanced systems like Rasa came into picture. At that time, we got some deep learning techniques to understand natural language, understanding intents, and instead of rule-based, we are speaking what we can say, switching to this decision-based system that we can use with this artificial intelligence technology, or what we can say complicated deep learning models. So that is something this evaluation happened over the years from AI to ML to AI. So coming to these key concepts in AI, typically machine learning, this learning is classified into three model types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is typically things or scenarios where we have predicted outputs based on some kind of features. So let's say we have some sort of features, and at that time, what the prediction has been occurred, or how sort of performance has been completed, or the data is given or not. So we have some label input data set, we have some label output data set, and based on that, we have got some what we can say decisions. So that decisions help us our model to learn, and based on that, from previous pattern, it is getting identified, and what will be the scenario for upcoming inputs that we gonna get. So supervised learning is kind of scenario where we are having some sort of inputs and we are having some sort of outputs. Okay. So input, when I say there are some parameters that is input is getting defined. When we say, let's say email classification or spam detection is the scenario. Okay.
Mm,
So in this detection, there might be multiple inputs. First input is, let's say, sender of the email. Second input is the say scenario time of the email. Third input is the scenario subject of the email, and we are having an output that is whether that input is classified as a spam or not. Okay, so let's say we get an input. First input is like as I already mentioned, sender of the mail. Let's say
mm,
sender of the mail is some no reply mailbox. Okay, second is sending time, it is some random daily time, and third input type is subject of the mail. Subject of the mail is kind of urgent. It is specifying some thread, or it is specifying some kind of emergency that one should look at. So or what we can say, these are some input parameters that machine learning will learn from the previous data, and it will tell us whether that email is a spam or not. Okay, so if
okay.
you have any sort of previous scenarios, like we have previous what happened in previous case, then based on that, ML models will learn that scenarios and will generate those output. That is the simple thing. You got my point?
Yep.
Okay. So coming to the second scenario, unsupervised learning. So unsupervised learning is something that is working around unlabeled data set. Like you are having data set that are not having what we can say predictors or output, but you are just having set of input. Okay, so there
Mm,
is no decision making parameter like why these inputs are here and what we can do with them. So at that time, this is used for something known as use cases like clustering. Okay, I'm sorry. So clustering is just what we can say, uh, separating out the parameter or input of data into some clusters. So when we say cluster is a group of data points. Okay, let's say hypothetically, let's say we have some 100 points. Okay, in that 100 points, we are having some information about the what we can say customers that are in our banking data. Okay, let's say we are running a bank, we have 100 customers and we have their 100 data. Now I want to classify this customer into some clusters. Okay, these clusters will give me some decisions to derive on and how I can approach these customers on the basis of marketing scenarios. I'll divide these customers into three clusters, one, two, three. 100 will be divided into 30, 30, 33, let's say. And these clusters will define me how to approach this customer for which policies and all. So how can we divide this cluster into three parts? So here we'll be dividing some data points. That data points will, what we can say, took all the similar points with them. Let's say there might be some customers which is having less spending habit, or let's say high civil score, or let's say their what we can say account range is kind of minimum. So here will be we are not providing any sort of what we can say loan opportunities more, or we might just provide some sort of what we can say policies or something like that. We'll make some strategies. So defining customers on set of some what we can say spending habits, spending parameter it has, and that can be done with the help of cluster. So this is grouping of similar data points. We'll just group the similar sort of customer face that we have, and we'll just approach with the strategies that we have developed for marketing them and getting some ROI from them. So that is something that is used in this unsupervised learning case scenario.
Aman,
So here,
especially the
mm,
example which you take, right, which you took
mm,
about customers in a bank. So
mm,
when you clustering, it's about assigning attributes, right? So let's say you're
mm,
trying to group customers based on certain attributes, like maybe the demographics or maybe the spending
mm,
habit, right?
mm,
Or maybe
mm,
the amount which they keep in their account, right? So that's
mm,
what you're
mm.
saying, clustering, dividing
Right,
customer.
exactly. Mm. Just like grouping them so that we can, instead of using this what we can say scattergun approach, we'll use fixed shot approach to market them, like so that we have similar patterns, right? So that is the thing. Then there is something known as reinforcement learning. So reinforcement learning is kind of uh, pattern in machine learning where we work around reward and penalties. So this is one key component in training of large language models as well. Okay, so it's really complicated. Like researchers are still going around with this, and it works on only big data. So whenever we are having some sort of big data, then while using this reinforcement learning will be an what we can say a best example to go with. Okay, so the specific example while working with reinforcement learning is like recently that Amazon has launched kind of vacuum cleaner that not vacuum cleaner, we place it, it's just like it looks like weight machine, right? So it goes inside your home, looks at places. So if it blocks at some places, it goes into another places. That is some big simple example of reinforcement learning. So here we are creating some agents that will use reward and learn penalties based methods. So if it is getting if it is doing some good work, it will get rewarded, and if it is getting blocked or getting some what we can say avoiding work, so it will get penalized. So based on penalized, that model will learn that you don't have to do these things, and based on rewards, it will go like you have to do this thing to avoid this to get the model better. So these reward and penalties are key components in reinforcement learning. Still, while working with AI, most of the time this remains in black box approach. Like most of there are codes, there are researches are going on, and there are use cases. But like while working on key data science, reinforcement learning is still way what we can say ahead while working with this data science for most of the teams. So yeah, that is some key concepts in AI that one can classify. I hope this is clear. We can go into next one. So yeah, as I already mentioned, core services about GCP for AI. So while developing any app we have in our local, while making it deployed for what we can say multiple people across the globe and scalable and using making it more powerful, these are some GCP services required from AI side. So I'll just show you something. Whenever we go in this GCP infra, okay. So we are here, and here we can see some sort of API and services. So these are some primary services that I've used on. So I am an admin. If I look at these services, this is particularly used for authentication and assigning roles and policies and whatnot. So marketplace, here are some what services provided by GCP that we are gonna get in quick access. Apart from this, computer engine is using your virtual machine. like how we can use your virtual machine on GCP. For that, we need this service. Kubernetes engine is something it is used for deploying your app for large audience and scaling up your horizontal pod, vertical scalar, and scaling up your machine with the load that it gets. So Kubernetes engine. So Google has provided their GKE, Google's Kubernetes engine, where we can create clusters, where we can review the workloads, where we can assign the teams. Here you can see AI is new section is brought out and whatnot. So cloud storage, where here we can store our data. It is in the form of buckets. We can monitor our data, and apart from that, that's this data is this the problem that I mentioned, right? Most of the clients look at HIPAA compliant platform, so it's a completely HIPAA compliant platform. GCP will not allow any sort of unbiased users for this for third party APIs. So apart from this, there is something known as BigQuery. So BigQuery, here we can build the data pipelines, we can create play around the data and handle biggest transactional any sort of data, not transactional, with the faster processing time. Then there is something known as VPC network, so virtual private cloud network, if I'm not wrong. So it will create us allows these services to bring our own internet protocol address, and it will create. Let's say we are building one network. Let's say we are creating a visual path network, and you, me, and Naveen are working on that. So in this network, let's say we want to create our own IP and we want to share our rules and we want to share our protocols inside that. So this might be the service we are going to look at that thing. Apart from this, there is something known as Cloud Run. So Cloud Run, in simple way, if you want to develop an app and that should be accessible to few of people. I don't want to make it global. I just want to test it. So at this time, Cloud Run will be a service that I'm gonna take a look at that. Okay, let's say we have built one app, it might be POC, and three of us want to get it access of that. At that time, I'll be gonna looking at Cloud Run. Then they have their own SQL. This is gonna be like plug and play things like we do for query, and for security, all sort of privacy. How can we and manage our things and what? So these are some high level overview of the services that we have. Okay. So coming to this core GCP AI services, we have something known as Compute Engine. So Compute Engine will provide a scalable machine to train and deploy our ML models. Not just ML, DL models, NLP, anything we want to scale, we want to use beyond our machine. Let's say most of the time we are working on Mac, say, Mac or what we can say Windows system. For a complex project, I will say Mac. So at that time, instead of getting local support, this cloud-based support, GCP support, it's kind of flexible. We might scale up to whatever instance, GPU instance we require. It might be from NVIDIA T4 basic one to NVIDIA P100 complex one that we can get for a simple account, simple or free trial. Then we this compute engine will provide us what we can say comparatively faster computation power than that of conventional local machines or notebooks as well. Then we are going to cloud storage, as I already mentioned, as we have the GCP provides their own buckets, so where we can store the large data sets, and we can use this for training and storing our data and using it wherever required. So cloud storage, all as I shown you on dashboard, so that is one thing that we can use for. Then there is something known as BigQuery. So BigQuery is kind of analytics service provided by GCP, where we can analyze large AI data sets. Where later on we can use these data sets to what we can say queries to build this data pipelines and format our data in whatever sort of analytics data that we want to make and use that. So this is something that we have to look at once again. So apart from this, there is something known as AI and machine learning APIs. Okay. So as I've already mentioned, using developing your models from scratch is not always a good idea. So GCP has provided their own sort of what you can say pre-trained APIs. It might be computer, it might be vision based, it might be speech based, it might be NLP based, and it might be translation based. So I just show you a scenario how these APIs can be used. Okay, let's say we have some set of business cards and we want to extract what you can say name, contact number, and let's say what we can say organizations information from that business cards. We're having around thousands of business cards. Here, instead of building our own computer vision model, deploying it from scratch, developing it from scratch and deploying it on the cloud, we'll use these GCP's vision models. We'll give these thousand sets of data to this GCP model, and it's what it will the project is on inside our own infrastructure. So this data will not go anywhere, because we are storing it in cloud storage, and it was not going to leak anywhere. Okay, and then we'll program it in a such a way that it will just retrieve our details that we are asking for. So instead of going for deep learning services, understanding computer vision, understanding what this sort of technologies that we have to look at, we'll just go into this vision based APIs. We'll ask to generate whatever sort of information that we are looking at. So
Aman,
this,
sorry,
yes,
you talked
no, no, no,
about
please.
so you
Hmm.
talked about vision API, right? You talked about this use
Hmm.
case of, let's say that we want to extract information from the business cards, right?
Hmm.
That involves
Hmm.
providing those business cards as an input image to this vision API, right? And then extracting
Right.
text. So in that perspective, right, you are saying that we can still ensure that the data doesn't go outside of your organization boundary, right? Like
Yes.
how do
Yes.
you manage that? Because obviously these APIs are built on, large language model
Hmm.
Google owns, right? And on top of that, we
Exactly.
have API. So how do you ensure that?
Sure. Yeah.
Yeah,
Yeah. So when we code this Google Generative AI client, right? So here we
mhm,
are clicking on new project. Okay. So when we
okay,
create a new project, okay, all sort of services or all sort of APIs that we are gonna get, that will be inside our this project only. It is not a API key that just like we use like OpenAI API key, right? So
right.
just OpenAI takes our data. It's not simply like that. It is
Mm-hmm.
the all sort of infra will be inside this project, and it will be inside this organization. Here it will here your organization name will come and all. Okay, so all sort of interconnection that will be there, it will be inside your organization, it will be inside your projects. And Google, GCP has provided their privacy document. I'll just show you later, where they cannot use this data, and all sort of this data is HIPAA and GDPR compliant.
Yeah, I
So that's
understand
it.
that you work under organization, right? So let's
Hmm.
say that you are working for one organization, let's say Aetna, which is a healthcare provider, right? So obviously
Hmm.
Aetna will be set up as an organization in GCP, and then all the
Hmm.
GCP services we are accessing, right? That will be under
Hmm.
that organization, and it won't cross boundaries. My question was like, is there
Hmm.
a commitment from Google, or like how do they say that? Okay, I mean the data which you're inputting to our APIs, let's say for vision we are providing these 1,000 business card, right? That they not
Hmm.
extract information from those and use it for their learning. I mean, you're saying they
Yeah,
publish some
yeah,
privacy document to state that
yeah,
yes.
yeah. They have provided some commitments and privacy
Okay,
documents that they are not gonna use this. Okay,
okay,
so that is how it goes. Yeah, we
okay,
were
okay.
not also sure about that. Recently, we have used this Vertex AI services. Okay, and we have built one internal chatbot where we can, what we can say, do some chatting with the policies that one healthcare has. Like
Mhm,
let's say there is some claim settlement scenarios.
mhm,
Then in that claim settlement scenarios, there are some documents like loss run, border X. So these are some documents when a patient files a claim. From
mhm,
that, the claim goes in what we can say under that trials and everything, the transactional amount and what organization has to pay or what patient has premium over the years. So that
mhm,
all sort of policies is coming under around 100 to 105 pager policy. Okay, so that 105 pager policy that we have now, that policy goes to claim adjuster or underwriters. He has to go into this all policy once again, understand that. So instead, we have created a solution where we can chat with this policy. Now you can understand the level of policy data that policy has, understand the what we can say scenarios. So at that time, the client itself told us like GCP provides these things, and we have that client was also having IT team, so we have just implemented that. So that is something that I can, why I can confidently say about this.
okay. So you are saying that, I mean, the project you created is more of assisting the claim adjusters, right? So instead of them
Exactly.
at 105 pages for each claim, they can use your
Hmm.
chat box to query that information and decide accordingly how the claim needs to be processed, right?
Exactly. And that scenarios, the data was also what you can say very sensitive, looking at
Mhm.
the patient's information and all. So
Yeah.
that even also kept in GCP side for this with this guarantee in mind.
And were you storing that data in like in GCP database, or like how in the vector DB, or like how you are storing that information?
Like GCP provides AlloyDB as a vector database service.
Okay.
So yeah, that where I was using that.
Okay. Okay. Got it. Thank you.
Thank you. Yeah. So this was something about APIs that I already mentioned. And then
Mhm.
apart from this vision use case that I provided, there is something like speech use cases. Let's say we are developing something text to speech or speech to text. At that time, also GCP has their own model. If we can look at GPT-4 Mini, which is provided by OpenAI, it's
Mhm.
an model. It can work with text, image, and any sort of data sets. So GCP had their own models like Gemini 1.5 Pro, Gemini 2, Gemini 1.5 Pro Flash. So these are some things where we can use vision models and work with that around. So apart from this conventional NLP task, like if you remember named entity recognition, this is something that is initially was very popular in the market. Then there is something known as topic modeling. Let's say we have some large set of PDF and we have to define what that PDF refers to. So that
Mhm.
is something known as topic modeling, understanding the context of topic and naming something for that. So these conventional tasks of NLPs are directly eliminated by these large language models. And this GCP or any sort these cloud providers that provide their own API, and as they have commitments, we can work with simple and keeping our eyes closed, and we can work with that. And apart from this conventional translation task that can be also done with this based on machine learning APIs, AI and ML APIs. Okay. So apart from this, there is something and most important thing that we are looking at is gonna be the Vertex AI. So it is an end-to-end ML, LLM, and any sort of conventional AI platform AI things that we can manage at a single platform. Let's say we are developing a simple machine learning model, supervised learning. We are having some input, we are having some output. We have developed that model. We are using our Flask app, and we are viewing that result on what we can say front end with the help of HTML, simple
Okay.
HTML. Uh, and in this scenario, we are not managing any sort of model, what we can say, model training. Okay, so what will happen? Let's say later we got some data drift, we got some difference in the logic that we have built to understand this ML model, and there is some new sort of logic is coming. So at that time, we might observe something known as drift in the model. So the model that we are performing is not going to perform well, so at that time, we might need some monitoring at place, monitoring of machine learning models. So at that time, what will go? We'll go at ML flow. We'll use this ML flow in our conventional ML based flow, and we'll start observing our model on ML flow. This is good. But the thing is, like we are using ML on one infra, we are going for ML flow on another infra. Then we are using DVC data version and control to keep the track of the data version, version that we have, scenarios that we have. So it's like keep using ML models, but from three platforms we are taking access. So instead of that, we can use Vertex AI simply to build our models, simply to train our models in their notebooks. That might be the cloud notebooks, NVIDIA instances, or GPU or TPU instances that we want, deploy it with the cloud run or what we can say Google's Kubernetes engine, and then managing it with the help of Google Vertex AI only, right? So instead of looking at ML flow for hyperparameters and how the model flow behavior works, so we can look it at the Vertex AI only, and we can manage it at that level only. Okay, so this will be helpful for training, deploying, and then managing our AI
So,
models. So that is
uh,
some, yeah.
yeah, man. So how
Mhm.
different it is from, what, using these hardcore AI. So in point number four here, you talked about
Mhm.
vision, speech, and other APIs, right?
Mhm.
So let's say
Mhm.
I am working on a system, right, which
Mhm.
basically captures the audio and then translates it into actual text, right? So let's say you upload a
Mhm.
audio file, let's say of like of 1 minute where two people are talking to each other, and then you use these pre-trained APIs, right, to extract
Mhm.
text from it, right? So in that
Mhm.
perspective, right, if I'm building an application, right, let's say it's a
Mhm.
simple application, it has one HTML page where you're uploading an audio
Mhm.
file, and then we are calling
Mhm.
this like AI APIs from GCP to convert it into a text, and then it responds back to us in a JSON, and we just
Mhm.
display that on the UI. So on this scenario,
Mhm.
right, I think
Mhm.
we will not be going to Vertex AI, because that is more of a whole platform to manage everything. We can just use
Mhm.
this pre-trained API vision, speech, and all, to build our product. I'm just trying to understand like how Vertex AI is different from using those predefined AIs which you covered in point number four.
Okay, so Vertex AI is a kind of platform. Okay, let's say
Mm.
you're developing something on Jupyter Notebook or PyCharm or something like that. right?
Mm-hmm.
So getting all these services at one point, that is a task of what you can say service that Vertex AI provide. Okay,
Okay.
so I'll just show you the UI of Vertex AI. I think it might be accessible on UI images. Okay,
Mm-hmm.
so we can get this ML based things as well. So whenever we are creating our data, how it is going. So this is kind of AutoML thing, like understanding how the data is flowing, data flow thing, right? So here you can
Okay.
see data is created, data is getting just. I'll just show you this image. Yeah.
Okay. Mm-hmm.
So this is something like your data is getting from this Python 3.7 environment. It is
Mm-hmm.
train divided into train and test. Then we are using XGBoost train model. Then we are keeping this model. We are using this matrices as well. Then this model is being uploaded to this model registry. And here we are accessing. So this is some all at a Vertex AI services. It is you're telling how your services are working around. Okay. So giving
Okay.
an overview. Okay. So
So
this is
essentially, you
part.
are saying that it provides the whole framework of developing applications, deploying those, and what, making them learn from the execution and all. That's what you're saying.
Exactly,
Uh,
exactly, and it is like what you can say, all places at a one time. I'll just
Okay.
yeah, this is services. Like we can get this data
Oh,
sets, we can get notebooks, we can train, we can track our experiment, we can look at the models, we can build our endpoints, we can
okay.
create some batch predictions. So these all sort of services will be accessible at one point, and yeah, that is something about Vertex AI.
Okay. And have you, in your professional career so far, Aman, like have you started consuming Vertex AI, or you are using those Vision Speech and other inbuilt APIs?
No, no, I use Vertex AI as well for this
Okay.
ML based models. Mhm.
Okay. Okay.
Currently, I'm working on this, but Vertex AI for ML based model, and now Vertex AI for LLMs is also launched. So, as I already mentioned, Vertex, if you look at Vertex AI for
Mm.
LLMs or generative AI, okay. So, these are some recently launched services that I'm working on from around 8 to 9 months. So, here we just like machine learning models, we can use this ML based models as well. Okay.
Okay. And
So,
I'm sort
this
of
will be.
yeah. I think okay. Okay. Good. Ready, sir. Okay.
Hmm. So here you can see, I don't know whether this image will be clear or not. Okay. So
Yeah.
here
This is
user will go into this LLM or what you can say app. Here we are having some data cache and chat memory in this
Mhm.
data layer. And you are using this Palm tool. So this is now, I think, outdated LLM. Complete
Okay.
things are on Gemini.
Mhm.
And here we can set up notebooks. So this is how the embeddings will load and data set will be there and answer will be generated. So this sort of scenarios in Vertex AI with
So
LLM, I've done that.
yeah. So if we give you a use case, right? I'm just trying to understand the Vertex platform, right? So if there is a
Mm,
use case that we have to build an app, okay, host it in Kubernetes. That app is
mm,
responsible for, let's say taking user input, let's say an audio file, convert it to a
mm,
text, display it on the portal. You are saying we
mm.
can do all of this within the Vertex AI studio itself, right? Platform itself.
Exactly. Exactly. We can use this Vertex AI to build and develop some everything. And for production, as we go to GKE services. That is the simple thing.
Okay.
Okay,
Okay.
so this is something about core services of GCP AI. Okay, then we are going at advantages of GCP AI. So we have this GCP AI for scalability. So massive any sort of AI workloads that can be scalable, that can be provided by this GCP. Then, as I already mentioned, we have this pre-built AI models. Sorry, pre-built AI models.
Mm.
So what you can say, these are ready to use as from Gemini 1.5 Pro to any sort of vision model, image models, and speech models that are easy to use. We just have to plug and play. Just that's it, that like thing. Then it is cost effective. So whenever we are using some sort of services, it was built per second billing. Okay, so ensuring only pay for the use resources that we are used. Okay, so this is something like most of the time what happens, services are getting run. So GCP Pro takes their own cut, and apart from that, if you are using that service per that much of time it will bill that only. So some amount for keeping that service running, and some amount for keeping that service used. So that is some parameter of cost effectiveness that GCP provides. So, and coming to this security and compliance, GCP provides HIPAA, GDPR for US healthcare, as you were working on that scenarios also. So we ensure that security and compliance is that revolved around GCP with that scenarios as well. Okay. So then apart from that, integration with Google products. So GCP it can get integrated easily. So that is some seamless integration with any sort of providers that GCP services has. There are around 40 services that GCP can be integrated with, and it is easy integration that GCP provides. So basically, these are some theoretical points that I have listed. One can understand it while working with this GCP side more.
Okay.
Okay. So coming to this benefits of GCP, using this GCP for AI and ML projects. Okay. So GCP provides something known as AutoML. So AutoML, let's say we are working, so we are, take a scenario, we are not having this much exposure to data science. Okay, we are something on Java developer side or testing side, and someone asks us to build some sort of machine learning based model and use some automated approach. So then we gonna look at this AutoML service. Okay, so AutoML will ask us to will help us to develop this model without any sort of expertise, just like plug and play things. The UIs I showed, right? Their data is flowing through these models and all. So just kind of plug and play things we can do around that. So we don't have to look at the hyper parameters. We don't have to look at data, what we can say, complex data sets, complex patterns. So AutoML will just ensure us and will keep us an upper hand. So that will not that will save our time from getting understanding the core data science, core ML concept, and it will help us developers or anyone train the models without getting some sort of expertise. So that is something that AutoML services provides. Then then GCP uses TPUs. TPUs will provides TPUs will accelerates the deep learning model training. Let's say we are building a deep learning model, as I already mentioned the scenarios, right? Business card, and we are extracting the data from that business card, and that scenarios we are working on. So here, if we go at conventional CV model, computer vision models, we might have to set our boundary boxes. We might have to set the parameters like, so what will be the size of business card, how the image will be, how the pattern will be, how the bounding backs are of the what we can say business card will around revolve around. Let's say one business card is having a Romanic font or Times New Roman font, other is having Arial font. So we have to load all sort of fonts in our deep learning model. So we can imagine the scenario. The more complex data will get, the more complex our deep learning model will be. And at that time, if you anyhow, let's say we want to build that model only, a deep learning model will be so heavy that it won't even run from GPU, complex GPUs. At that time, we can go with 10 TPUs as well. So all sort of deep learning models that we are looking at are almost heavy. They can't even run on CPU side. So at that time, we need GPUs. And let's say we might need the scenarios where we can go for the more complex operations. We can go for TPUs as well. Okay. So data and
Sorry
AI
to cut in.
integration. Yeah.
Aman, please can you go little slow?
Oh, sorry. Sorry. Please tell me, okay? So I'll just tell you simple thing. So ML-based models are simple supervised and unsupervised learning models, right? So to train that model, we don't need that much what we can say computational power of thing. Okay. So when this ML-based model runs up, what we can say runs from this business, what we can say runs from this complexities, we go for this deep learning model. So when we develop any sort of deep learning model, it's kind of heavy. Okay. So developing the deep learning model on your own CPU is kind of challenge. So at that time, we go for Mac. We develop our own model of deep learning on that Mac. Again, deploying that model and making it scalable, it needs again more infra and more hardware. So at that time, for extended GPU or TPU support, GCP provides specialized AI hardwares. Okay, so all sort of configurations that it has for GPUs and TPUs that can be easily accessible within this GCP infra. So that's why I was just telling this point that deep learning models are quite heavy as compared to this machine learning models. So that's why GCP will provide you dedicated support on this GPU and TPU side which will be an upper hand or ease for you to develop your deep learning models. Now it is clear, or should I explain again?
Yeah, yeah, it's clear now.
Okay. Then coming to this is the simple what you can say. This is the most important point I must look at. So this is something known as data and AI integration. So let's say we are building some seamless pipeline that might be with BigQuery, data flow, and all. So what is data flow? Let's say you might be aware about sequence diagram, right?
Yep.
Yep. So GCP has provided an AIS, what we can say, sequence diagram on their own infra, if I have to say in layman's term, that is known as data flow. Okay. So any sort of pipeline that you have built with any sort of BigQuery tools, data pipelines, ETL type pipelines that we have built, we can visualize with this data flow. Okay. And other sort of APIs are also there. So we can plug in this ETL pipelines with AI integration that might be from ML based APIs, that might be for LLM APIs, that might be for AutoML APIs. So getting your data accelerated into one platform, that is being and what we can say, that is an easy thing that we can go with the do with the help of this GCP. Okay, so this is data and AI integration that will be playing an important role while using these GCP services. And then cost efficiency, they provide a flexible pricing model for startups and enterprise. And I remember one scenario, like one of my friend was working in startup, so he started working in GCP. They don't have any sort of infrastructure or architectural support on their end. So for what you can say, using these GPUs, they have reached out to this GCP GCP, and they scheduled a meeting, and everything happened well. And within that discussion, GCP provided them and what you can say free of cost infra support. Okay, they ask us for their use case and provided an infrastructure reports like which sort of services that you can look at. That is also free of cost. And just my friend who is a developer, he has to work accordingly to integrate that services. Okay, so that is something that's a good thing I observed from the GCP side while working on that scenarios. So building your own infra, even if you are not able to build your own infra, they'll guide us how you can build your infra, and you have to work on that. So that is something on GCP side. Okay, then all last points that we have studied, I'm just comparing it with the GCP and Azure. Nothing complicated or nothing thing. I just created this diagram from this what you can say chat gpt only, just some sort of database that I have created and point of comparison, and this is something that we have to look at. So if I have to look at check-in points, just now what we are saying, it provides best in class AI tools, Vertex AI, AutoML pre-built APIs that we have. Okay, then powerful hardware acceleration that we have seen in last slide. It provides TPUs for deep learning models, and something that is known as seamless integration with Google AI research. So any sort of research that let's say it might be going on this generative AI side, it will be coming with this what you can say services that provided by GCP services. Okay, so this Vertex and LLM hosting that I shown you, right? Redis and a use case that what we are looking at. So that use case just came in this around July. Okay, so the problem was the clients or scenarios were in such a way that people were able to use this GCP's Gemini 1.5 Pro and all, but they were not sure about this data privacy. So at that time, Google understood this is the client requirement, this is the requirement over the globe. So they have launched Vertex and the LLMs. So any sort of technology or advancement that is coming, GCP will take what we can say and take an upper step and will go integrate their service into this advancement. So that is something that one has to look at, and it is a cost-effective AI solution per second billing that we are looking at. So as we are working with GCP, we'll say GCP is the best for all comparing with all sort of services that is provided over the thing. Okay, so yeah. So coming to this, as I already mentioned, we'll go on some hands-on demo with how this Vertex AI API services and credentials are gonna happen. Okay, so I hope this is clear now. I'll just tell you a simple use case that we can look at.
Okay.
Okay, let's say we have developed an simple app, Hello World. Okay, and we want a authenticated list of users on that one. I don't want anyone who is apart from my authentication who has to look at that hello world thing. Okay, so here what I'll do, I have created an app to set up this hello world app. Okay,
Mm.
don't look at this complex code. I'll just show you this infra how it looks like. Okay, so okay, you can see I'm using this hello world. Okay, so I don't want this hello world based on this. This hello world should be displaying only after one user should logs in inside my GCP infra. So what we have to do, I'll go in this infra. I'll just go start from this port scratch thing. I have my generative language client project. I'll go here. I'll click on API and services. Okay. Here I'll go on credentials. Here I have already created credentials. I'll create new credentials for you. So here we are using this OAuth client ID. Let's just understand the flow first, then I'll explain it how it works and all. Okay. So we are creating an application. Let's say we are creating a web application. We are keeping this name as web client 3, and we are creating a set of UDirect URLs. So this UDirect URL will be something that once your app is getting authenticated, that will be redirected to this scenario. When we are developing on cloud, we'll deploy the app on the cloud, and that app will generate a URL. So we'll keep that URL here. As of now, as I'm running it on my this local system, I'll just create this authentication and we'll create it here. Okay. So let's just, we are creating some applications. Here we are getting some sort of client ID. Okay. We are copying this client ID. Then, oops, where it is. And then we are getting some kind of client secret. Okay. Now we have these three things in a place. What is this? This is a client ID. It is used for authenticating your app, and this is something known as client secret.
Mhm.
I'm just listing this. Then I'll keep this in my code. Okay, here you can see I have client ID and client secret. I'll just copy paste in this
Yeah, yeah.
things to authenticate my app. Okay, then I'll go for client secret. I'll just get copy. Okay, now these things are done. Now, as you can see, my app is saved. We have created this now. We are creating client ID and client secret. When you look at here, we are keeping this callback URL as this thing. Okay. Now I'm just running my code. Okay. It is opening something known as
Mhm.
this URL.
Yeah.
This URL will ask this me to sign on. Okay. I'll just sign on. I'll click on continue, and then only I can see this hello world. Okay. So this is something known as single sign-on authentication. So what we have done, we have used this sign-on authentication to protect our app from unwanted set of users. So later on, I can go in again in infra. I can use another services like IAM and all. Okay, here I can add you guys as a user, and you can also use this with this help of this client ID and client security. What it will do, it will protect our sort of scenarios. Let's say we are building this, as I already mentioned, like scenarios, right? Where
Mhm.
I was working on that chatbot, where I don't want anyone outside my organization to look at the chatbot. At that time, I can create these permissions and I can add you guys as what we can say, what we can say, user and all. Here, user and all, so that you can also access my app. So that scenario, I want GCP authentication only. So at that time, I can go with this sort of things. Okay, using this client ID and
Uh,
using this sign.
and when you do this, right, Aman, so you're saying that when your app opens, right, Google
Mm,
user needs to log into the GCP platform, right, and then it will generate a
mm,
session token. Based on that, only you
mm.
basically protect.
Exactly.
And can you run it again? I just want to see like how does it work. So when you run, right, it redirects you to the login page of the Google Cloud, right?
Exactly. I'll just copy this because now it is running and I haven't provided cache thing. So I'll just run it in this browser. So it will,
Okay.
oh, it's already running. So that is the
Maybe
thing. It will now,
you
okay.
can do a
I'll just,
incognito, then it will work for you.
yeah, I think. Mhm. Yeah, I think I have to log in again because I haven't logged in here.
Okay.
Basically, basically it's like if I go, I have to go and build a sequence diagram for that. What it will
Mm-hmm.
do? We are going to, we are using this Flask API, right? So Flask API will go to this GCP. Okay, GCP will generate something known as callback URL. Okay, this callback URL, this will be based on our client ID and client secret. Okay, this client ID and client secret will help user to authenticate, and it will generate this what we can say single sign-on page. So once we
That's
sign on that, yeah, yeah, yeah. Once we sign on this thing, we are getting our app displayed, or what we can say hello world displayed.
okay.
So this is
So I,
something like, hmm,
I have quick real questions.
yeah,
So we are not passing the client ID and client secret in query string, right? In the callback
right.
URL. Then how it's identifying but client ID and secrets we are using in our application.
Hmm. So thing is like we are using this auth URL, right? So it will redirect, and here it will check what we can say customer and client secret thing. So this URL will provide us an authentication window with URL. So it is provided by OAuth 2. This is 2.0 authentication.
Mhm.
Let me just create a sequence diagram for this. That will be better. I haven't used this in a long time. Wow, it's creating now. I thought it will create a text-based sequence diagram. This has made me so much lazy. Just keep it here. Okay. So we are
Yeah.
creating a request to Flask app, and if the user is not logged in, it will redirect to this login, and this redirect will be this Google Auth URL. Okay. Then the Google will ask for consent. User grants for consent by clicking on continue. Then this will redirect to this callback with code. Okay. And there will be some request of access token. This is some temporary access token that will be generated. And once this is generated, it will be stored in session. That's why whenever I'm logging in again back, right? So that access token is again stored. So it's getting directly called to this URL. So then let's say redirect to this URL and it will return to hello world. One logout option is not added, so that can be added for the sessions and it can again log in. So that's simple flow. I created this while implementing an role-based access to flow. Later on, I just got this in the 2 days back while I was doing this demo session. So yeah, I remember like it. It's something that one can look at in front place, right? Easy to understand and all. So
Yes.
that's why I wanted to keep it.